So now we're going to start looking at cycloalkanes. So cycloalkanes, as you might have guessed from the description, are when we have a series of carbon atoms that form a ring. And so the first thing we need to be able to do is we want to be able to talk about how we name them. Now, one of the challenging things becomes, when is the ring the parent and the chain the substituent? And when is the chain the parent and the ring the substituent? Well, it probably wouldn't surprise you to learn that in a case like the one on the left, given that the straight chain has more carbons than the ring, that the straight chain is the parent and the ring is a substituent. And on the right, the ring has more carbons than the chain does, and so the ring is the parent. So let's do a little bit of nomenclature here. There's not a lot new here. If we consider the rules that we learned for alkanes, then there's really not much different going on. So we're going to name this compound here. And you'll see why in a moment, but I've drawn out the same structure 3 separate times. So the first thing we need is the parent name. And we can see the ring here has 6 carbons. So we know 6 carbons is hexane, but because they're in a ring, we're going to call this cyclohexane. So that part's pretty straightforward. The parent names are all the same, except because they're in a ring, you put cyclo out in front. Then we can put in the substituents. You'll notice we have 3 of them. So this is trimethyl cyclohexane. So far that's all pretty straightforward and pretty consistent with what we've learned before. The only major difference here is how we number it. So if you think about a straight chain we can number starting anywhere, or starting at one end and ending at the other. So we only ever have 2 choices for how we number the chain. But a ring, because there's no true start point or end point, we can literally start anywhere and end it anywhere. Now the basis for how we do that is exactly the same as what we learned for alkanes. We want our first substituent to have the lowest possible number. But because we can start anywhere, that means it's guaranteed that one of our substituents is going to be carbon number 1. So what I'm going to do here is show us all the possible ways we could do it. So we could start down here at the bottom and go in this direction. If we do that, our substituents are 1, 4, and 5. We could also start at that carbon and go the other direction. That gives us 1, 3, and 4. So already we can see that our green numbers there are better than the red ones. All right, we could also start up here and go this direction. That gives us 1, 3, and 6. So definitely not better than the green. We can go purple here, the other direction. That gives us 1, 2, and 5. So far that's our best one yet, because it's the lowest possible first number, 1, and then the second number is also lower. But in order to be complete, let's do all of them. And you can see that one gives us 1, 2, and 4. And we've got one other option, which is to go the other way, which gives us 1, 4, and 6. So we can see clearly that this is the one we want. Lowest first number. It's one of two that I'll highlight in green here that has the lowest second number. And then we choose based on the lowest third number. So that's really the only thing that's at all different about cycloalkane nomenclature. Again, it's just a matter of picking where to start numbering and going in the right direction.